I've got a couple of problems for you to work out on the board here. I've given you this new area function where our height function is e to the tan t, but we're integrating that from 0 to x. So our area function is the signed area between this function and the x-axis over the interval from 0 to x. Do want to just remind you, because this is something where I see horrible notation all the time, that variable and that variable cannot be the same. There's no way x can be the upper limit of integration, which is either the left or the right endpoint of my interval, and simultaneously be taking on all values in between the endpoints. Okay, excellent. So I want you to find the derivative of that function at pi over 4, and then I want you to find the second derivative at pi over 4. Okay, so pause the video, then tune back in and we'll work through it together. Welcome back. I know that finding any derivative at a point is always a two-step process. I need to start by finding the derivative function. Well, the derivative function is just that function at x, so it's just e to the tangent of x. So a prime at pi over 4 is just e to the tangent of pi over 4. Tangent of pi over 4 is 1, and e to the first is e. Excellent. Now, if I want to find the second derivative at a point, that's also a two-step process. I'm going to start with the first derivative because I have a formula for that, and I'm going to find the second derivative. So here, this is something you could do before we learn the fundamental theorem. This is just chain rule. That's going to give me e to the tangent of x times secant squared of x. So a double prime at pi over 4 is e to the tangent of pi over 4 times secant squared of pi over 4. We already said that's going to be e to the first. Now for secant of pi over 4, that's a 45-degree angle, so I can draw my 45, 45, 90 triangle. Cosine would be 1 over root 2, so secant is just root 2. But I've got to square that, because we're looking at secant squared, so that's going to give me 2 times e. Excellent. Okay. So now, I'm going to define another function. I'm going to just call this b of x. And I'm going to make it the integral from x to 2 of the square root of t to the 5th minus 1 dt. And what I would like you to do is try to find a formula for b prime of x, and then use that formula to evaluate b prime at, let's say, 2. Okay, pause the video, give it a shot. Welcome back. All right, so at first glance it looks atrocious because I see this integral and this formula and all of this stuff and square root of t to the 5 minus 1. That looks complicated. But I'm hoping that this is simple, that this is just one of my area functions. So I check, do I have a constant? Oh, I don't. I want to have a constant here and a variable here, because that's how the fundamental theorem is set up, that the area function is defined from a constant lower limit of integration to a variable upper limit of integration. Okay, I can do this. Remember, if we switch the limits of integration, we learned that what that does is that just reverses the sign of the integral. But now I can say b prime of x, that's just the derivative of the opposite of this area function that I can create. But now I can use the constant multiple rule. That's going to give me the opposite of the derivative of this area function that now I've made match. And so that's going to just be the opposite of the square root of x to the 5th minus 1. That height function, but just evaluated at x. So that's a formula for my derivative. Now here, I specifically asked for that formula. If I had only asked you to evaluate it at 2, I would have still done this work to find the formula. Because of course, evaluating a derivative at a point is always this 2-step process. Find me a formula, and then plug in the number. So b prime of 2 would simply be negative the square root of 2 to the 5th minus 1. 2 to the 5th is 32, so this would be negative the square root of 31. Okay, excellent. Let's see, do we want to do another one now? Yeah, let's do another one now. So I'm avoiding calling it a of x if it's not a perfect match to the area function, but that b of x was related to an area function. It was just the opposite of 1. Let's try this. B of x equals the integral from 3 to x squared of e to the t cubed dt. Okay, and I would like you to find a formula for b prime of x, and then evaluate that at 1. We'll say at 1. Okay, pause the video, see if you can figure it out. Again, this isn't a perfect match to an area function, but it's related to an area function. So see if you can figure that out, then tune back in. Welcome back. Okay. So I know for just a regular area function, I would have a constant here and just an x here, just a plain old variable. That's x squared. So that's like I'm plugging x squared into an area function. That's a function composition. I know how to deal with that. I need chain rule. So I'm just going to write out what the pieces are. A of x, the area function in question, would be what I get if I just had an x there. This right here is that area function evaluated at x squared. Because if I took x squared and I plugged it in for x, that's what I would get. So if I'm looking at b prime of x, I'm taking the derivative of area at x squared. That would be a prime at x squared times the chain rule would give me a 2x. Now what is a prime? Well, I know what a prime of x is. It's just that height function, but evaluated at x instead. Now I need to evaluate a prime at x squared. So those x's in that formula for a prime are going to get replaced with x squareds. So I'm going to have e to the x squared. Oops. I'm sorry, I didn't mean to put a parentheses around that. I meant to put a parentheses around the x. Times x squared cubed. That's a prime evaluated at x squared, and then times a 2x. And I can simplify that a little bit because I can work out what power of x I've got. So I'm just going to bump that 2 to the very front. Then I've got e to the x squared. X squared cubed is x to the 6th times one more x will be an x to the 7th. Okay, so that just involved a little bit of chain rule. B prime of 1 then, I'm just going to take this formula and plug in 1. Okay. Now 1 squared is 1, so I'm getting 2 times e times 1. So we're getting 2e. Kind of cool. Okay. I'm going to put another one up on the board, and then we'll start the next video by going over this. But your job between now and watching the next video is to give this one a shot. See how you do. Okay. Let's suppose I've got the integral from 0 to sine x of the square root of t plus 1 dt. Okay. And what I'd like you to do is find me a formula for b prime of x, and then evaluate b prime at 0. Okay, so that's your job, and that's what we'll start with in the next video.